Okay, number 13 on page 350 of the new edition. This is a two-step proof. You folks at home need to have those rules handy as we put them on the board that explains what we use them for, because I can't get everything on the board with the wide view here. It's too wide. So, first thing we want to do is look over our premises. See what we have to work with, always. Line 1 is a curl. We use negations in exactly two of our argument forms. One's an extraction, one's a creation. You need to find out which ones they are and note that. It's part of the process. So let me know when you found out which ones they are. Rules of inference that use a negation as a premise. One's an extraction, one's a creation. Modus tollens is one of them. Disjunctive syllogism. So this is important. If that premise is going to be used in the proof, it's going to be used for one of those two. 99 times out of 100. I'm not going to bet my life on it. Line 2, many things we could do with a horseshoe. First premise of modus ponens, in which case we would extract L. First premise of modus tollens, from which we would create curl K. And look here, that's the conclusion we're after, curl K. That sounds promising. Could use a horseshoe for absorption, in which case our conclusion would be if K, then both K and L. Can use a horseshoe as either premise of hypothetical syllogism. You can always put two horseshoes together with conjunction and then use them as the first premise of constructive dilemma. So that pretty much covers what we could use our premises for. First question you need to ask yourself is, does my conclusion exist anywhere in the premises? If yes, then the last step of the proof will be to extract it. If no, the last step of the proof will be to create it. Our conclusion does not exist. We need to create a curl. There's only one way to create a curl. It's modus tollens. So we all know that the last step of this proof is modus tollens. So I'm going to give you a few moments to draw up what you know about that modus tollens, using variables for components that we're not sure of. Then we look around our argument, see what we have to work with. Well, obviously our conclusion is going to be curl K. We know our first premise has to be a horseshoe. And we know the second premise has to be a negation. That conclusion tells you what the antecedent of the first premise has to be. What, in this case? K. All right. Now, we don't know about these components right here, except that they have to be the same. Right? The second premise of modus tollens is the negation of the consequent of the first premise. So that's everything we know about our last step. You either need to do that mentally or write it down. Now we look around to see what we have to work with. We have an interesting situation here that is real common, although I don't think that we've encountered it so far. But this is very common. We have a premise, line 2, that resembles what we know about this. We have a horseshoe whose antecedent is K. And we have a premise in line 1 that, for all we know, resembles this. It's a negation. But there's a problem. Those are not the premises of modus tollens. Right? These components have to be the same replacement for Q. So what do? Well, you have to make the assumption that since it's a two-step proof, one of those is going to be used exactly as it appears, and the other must be adapted to it for modus tollens. If we make the wrong assumption, we'll find that out. We'll find out that it can't be done. And then obviously we need to assume that the other premise is going to be used exactly as it appears. So I'll do that. I'll intentionally make the wrong assumption. Let's assume that line 2 is going to be used as that first premise. And on that assumption, we'll take out this variable and put in L. So that means in order to complete modus tollens, we now have to obtain curl L. Right? Curl L doesn't exist anywhere. There's only one way to create a curl. So if this is going to happen, we have to use modus tollens to create curl L. So we'll draw it up again. We need a horseshoe and a curl. The antecedent of that horseshoe has to be L. Don't know about that, except it has to be the same as the component in the second premise. But see, we don't even have a horseshoe whose antecedent is L, right? So even if that could be obtained, it would have to be more than 2 steps. So what do we know about this assumption of using line 2 as our first premise of modus tollens? Yes or no?
No.
No, it cannot possibly happen, at least not in a 2-step proof. All right? So, no big deal. We made the wrong assumption. It's not line 2. It's going to be that first premise. Therefore, it has to be line 1. That's our second premise. It has to be. Now, on that assumption, for this variable q, we now need to somehow obtain that premise. We have one step in which to do that. Okay. That's a horseshoe that does not exist in the argument. So there are 2 ways to create a horseshoe. What are they? Dig them up. Hypothetical syllogism and absorption. Well, any horseshoe might be the conclusion of hypothetical syllogism. By any, I mean no matter how complex or what it looks like. But the conclusion of absorption is very specific, and that happens to be it. Which doesn't mean absolutely that absorption is the way to go, but it's a good assumption. So let's see if we can make that premise there, or draw the conclusion to use as a premise, by absorption. If you have the conclusion of absorption, you know what the premise has to be. Because the conclusion is a substitution for P horseshoe P dot Q. And the premise is P horseshoe Q. So if you have the conclusion of absorption, you know absolutely what the premise has to be. So what does it have to be in this case? Let me know when you find out. Thank you. Anybody not understand that answer? Okay. K horseshoe L exists in line 2. So that's the way this is happening. This then would be line 3, the proof. It'll exist when we get around to needing it. We'll put our 3 here for our notation. Just transfer that over here. That's all done on your scratch paper for the test. This is what would be on the test. In pencil, you simply write in your lines of proof. Absolutely correct in every way. Questions? Let's review what happened over here. When we drew up our modus tollens, which we knew for a fact is the last step of the proof, we had partial premises over here. We have premises in the argument, each one of which resembled our partial premises. Obviously, they didn't match up for modus tollens. It's a very common occurrence. So you've got to assume, in a 2-step proof. We only have 1 step to complete modus tollens in this case. One of those premises is going to be used exactly as it appears, and the other must be obtained somehow. So we assumed that line 2 was going to be the first premise of modus tollens. Couldn't happen. That means line 1 has to be the second premise of modus tollens. And that happened. Okay, questions about that proof? Erase. $14. Let's look over our premises and see what we have to work with. You need to understand line 1 is a potential premise of 2, obviously of 2 of our rules of inference, as a conjunction of 2 horseshoes. Which one of our rules uses a conjunction of 2 horseshoes as a premise?
Constructive dilemma.
Constructive dilemma. If you have the first premise of constructive dilemma, you know exactly what the conclusion would be. So when you know that, when we're reviewing our premises to anticipate what we might do with them, when you can determine what the conclusion would be, you want to. So if that were the first premise of constructive dilemma, what would our conclusion be? Well, we know more than that. We know exactly what it would be. M wedge O. Anybody not understand how he knows that? Okay. Line 1 is also a conjunction. And we only have 1 rule of inference that uses a conjunction as a premise. What is it? Simplification. Now, there's only 1 premise of simplification, so if you have it, you know exactly what the conclusion would be. When you do know that, again, when you're reviewing your premises to see what might be done with them, if you do know what conclusion you could draw from them, you want to determine that. So what could we have from line 1 by simplification right now if we needed it?
M.
No. Thank you. M horseshoe N. Anybody not understand how he's getting these answers? Okay. Line 2, a horseshoe, modus ponens. extract O, modus tollens, create curl N. Absorption, create N horseshoe N dot O. Hypothetical syllogism, no telling what the conclusion would be. And then we're ready to roll. Our conclusion, M horseshoe O, exists in line 1. Do you think we can simply extract that from line 1, and if so, how? In which case it would be a one-step proof, and it's not. So do you think we can extract M horseshoe O from line 1? Those are the extractions over there. So all you have to do is look over there or on your paper. Yes or no? No. So our last step is not an extraction, it's a creation. We need to create a horseshoe. There are two ways to create a horseshoe. What are they? Hypothetical syllogism and absorption. We can eliminate one of those because this cannot possibly be the conclusion of one of those two. And having eliminated it, then we'll know what the last step has to be. So which of those two can we eliminate? Hypothetical syllogism or absorption? And because this is not complex enough, for one thing, to be the conclusion of absorption, right? So we all know what the last step is now. It's not a guess, it's certain. So draw up everything you know about that hypothetical syllogism, using variables for the statements you're not sure of. That's the way to go. Okay, you should be doing this, or have done this. Our conclusion obviously would be line 4, and that's M horseshoe O. You know we need two horseshoes as premises. The conclusion tells you what the antecedent of the first premise has to be. What? Go, my pen's drying. What? And what is the consequence? The conclusion tells you what the consequence of the second premise has to be. What? Oh. We don't know about that. Except that it has to be the same statement or same component. So we'll use our variable from the argument form hypothetical syllogism. Okay, now you look around to see what you have to work with. Again, we're making an assumption here because we have partial premises. I think most people would assume line 2 is going to be this second premise because it's a horseshoe whose consequent is O. On that assumption, you take out that variable and put in N, because that is line 2 that we're assuming is going to be used. And on that assumption, we can take out that variable and put in what? N. Okay, well, M horseshoe N does not exist. Well, I'm sorry, it doesn't exist on a line by itself. But if we're right in this assumption right here, we need to see if we can obtain M horseshoe N on a line by itself. And if we can't, then we made the wrong assumption down here. We just have to change it. Well, M horseshoe N exists in line 1. Can we extract it from line 1?
Simplification.
Yeah, simplification. So again, it's so important to look over your premises prior to starting the proof procedure because we said line 1 can be used for simplification, in which case we would extract M horseshoe N. And now we want to. So that's the way it's going down. Line 1. This then is going to be line 3. It will exist. Well, that does exist. That will exist when we get around to needing it. And it's going to be line 3. So this is what we want to see over here, without the parentheses, right? Because that's wrong. What's my oh, well, the notation is right here. You remember about the sequencing of these numbers, right? 3, 2, not 2, 3. Any question about that? All right, there's our proof. Questions about that? Fifteen's in the back of the book. That's for you. So we'll do number 16. Again, we have a conjunction of 2 horseshoes in line 1. So you need to anticipate either simplification, because it is a conjunction, in which case we would extract what? Which is T horseshoe U. We can have T horseshoe U right now if we needed it. As a conjunction of 2 horseshoes, it could also be the first premise of constructive dilemma, right? Right. So if you have the first premise of constructive dilemma, you know exactly what the conclusion would be. What would it be in this case? Anybody? U wedge V. That would be the conclusion. And look at that. That's the conclusion we want, U wedge V. Not to say constructive dilemma is going to be the way. It is kind of suspicious, though, isn't it? Not much you could do with a simple statement. That could only be substituted for a premise in the 9 rules that is simply P or Q. See? So either premise of conjunction, the premise of addition, the second premise of modus ponens. I think that's it, unless I'm forgetting something. Okay, our conclusion does not exist in the premises. So we know the last step of the proof is going to be to create U wedge V. There are 2 ways to create a wedge. What are they? Addition is one of them. Constructive dilemma is the other. Now, I think I probably said on a couple of occasions, when you have that choice, probably you should consider addition first, because it's a real simple argument form. And if it's not going to work, we'll find that out. And then we'll go with constructive dilemma. As a matter of fact, in this one, I think both will work, but not in the same number of steps. So this brings up a real important point. I think I've made this before. It's just as important to know what cannot be done as it is to know what can and should be done. If you don't know what can't be done in the proof procedure, you're going to think you're simply not doing it right and waste a heck of a lot of time and get really frustrated. So there are two ways of interpreting when something can't be done. It's simply impossible to draw a conclusion that you need. It's impossible. Or else, it's too many steps. It can't be done in the required number of steps. So I could do this using addition. Let's see what happens. If I draw that conclusion by addition, I'll need as a premise u. I don't have u on a line by itself. But I do have u in line 1. And it's the consequent of a horseshoe. So I can extract the consequent from a horseshoe by modus ponens. The second premise would have to be t, and there it is right there. But I can't do that while t horseshoe u is stuck in that dot. But I can simplify it out of that dot. So the proof would be simplification, modus ponens, addition. It's a nice proof, but it's the wrong one. So it's not addition. It's the last step. That's good to know, because now we know what the last step is for a fact. What is it? Constructive dilemma. Go ahead and draw up your constructive dilemma using variables for those components or statements that we're not sure of. It's the way to go. Then we'll look around and see what we have to work with, what needs to be created, if anything. We'll go from there. Okay, so you should be doing this. We know for a fact it's constructive dilemma. So I'm going to go ahead and put in my notation. Line 4 is going to be U wedge V. We need a conjunction of two horseshoes. We need a wedge. It's the second premise. That conclusion tells you what the consequence of those horseshoes has to be, doesn't it? U and V. Don't know about these except they have to be the same thing. Don't know about these except they have to be the same thing. So that's everything we need. That's everything we know about our constructive dilemma. Well, again, we have partial premises, so we need to make a choice. I think the choice is obvious. We don't even have a wedge there. So not only do we not have a wedge, we're not even sure what it has to look like. But we do have a conjunction of two horseshoes whose consequents are U and V, right? So that's the assumption we need to make. Line 1 is going to be that first premise. On that assumption, we're taking out those variables and putting in T and T. On that assumption, taking out those variables, putting in T and T. So we have this ready to go. We don't have that premise. But we know this is the last step. That's the last step. So this has to be attainable. It's a wedge that doesn't exist. It's going to have to be created. There are two ways to create a wedge. You know what they are. Constructor dilemma and addition. Let's try addition, eh? What do you think? If that's the conclusion of addition, what does the premise have to be? T. Question. Is that a good substitution of the argument form addition? Are you allowed to do that? You see why I asked the question? We have two variables in the argument form, and we have the same simple statement in the actual argument. So are you allowed to do that? Well, we have two rules for substitution from a couple of weeks ago. Anything may be substituted for a variable. Have we violated that? No. Rule number 2. The same statement must be substituted for the same variable everywhere that variable occurs. For example, P occurs twice in our argument form. So the same statement has to be substituted for P. Have we violated that? No. Those are the only two rules. We haven't violated either one. That's a good substitution of addition. You need to remember that. You can substitute the same statement for different variables. You can't substitute different statements for the same variable. So that's addition, and that's the way this proof is going down. Line 2, it's ready to go. This then is going to be line 3. It'll be there waiting for us. Okay, so what's the lesson with that one? Got a couple argument forms that offer you choices. Choices to create a horseshoe, choices to create a wedge. Sometimes either one will work in the same number of steps. Sometimes either one will work, but one in a greater number of steps, so it's not the way to go. And sometimes only one will work. So in this case, we found out that addition, it'll work, but the proof is too many steps. Well, then we know it's got to be not addition, but constructive dilemma. Questions about that one? Are you all warmed up? Are you ready to go on your own? "17. Look over your premises, please anticipate what they can be used for. It should take all of about 2 seconds to determine what the last step of a proof must be. doesn't exist, it must be created, and you need to know how. If it does exist, it must be extracted, and you need to know how. That last step is the key to all prior steps. Who knows what the last step has to be? Modus ponens, go. Draw it up, everything you know about what it must look like. Using variables for statements we're not sure of. Look around to see what you have to work with. Start the questioning over again. Should have done that.